Yoongi sir. Actually, I came from the Harlem University and Department of Psychology. And first, I want to introduce myself. Actually, I got a PhD program, PhD in the University of Minnesota, Department of Psychology. My advisor, David Wise. But 2010, I got a job in the Michigan State Department of Education, and I worked 4 years in the psychometrician in the Department of Education, and then moved to Ohio, and then I used to work National Registry Emergency Medical Technician in Ohio, and 2015 finally I got a job in my country, assistant professor in the psychology department. So this work is actually done, and when I work National Registry Medical Examination in the Ohio. So the title is Comparison of 3 Empirical Reliability Estimates for CAT. So it's very simple, brief report, but just I think I try to explain as easy as possible. And now move on to here introduction. So actually there are lots of study about the CAT simulation and IRT and estimation and scoring in the paper and the real world, but there are very few research about the reliability in the IRT and computerized adaptive testing. Actually, as you know, there are 2 bakers in the measurement and the reliability and validity, but there is no very few about the reliability in CAT. So that's the reason why I just interested in the reliability in CAT. Usually, 3 methods was known to estimate reliability in CAT. So Nice-Wonder and Thompson 1999 APM was published. He used 3 methods, arithmetic, harmonic, and Jensen inequality to marginalize test information for estimating IRT reliability estimate in CAT. So however, their studies, the items were drawn from the item bank containing on average 80 items, fixed item, 80 items, which were longer than practical CAT setting. 80 items is not really CAT, kind of a conventional test. So that's the reason why I'm interested in this kind of reliability estimate in CAT. How many practical assessment programs often use interchangeably 3 IRT reliability. Here, arithmetic, harmonic, and Jensen equality in CAT, but specifically there are under several conditions which method is appropriate and efficient. There are very few research. So that's the reason why I'm here to study this kind of reliability estimate in CAT. The purpose of this study is to compare 3 methods of calculating marginalizing observed standard error. This can be expressed by inverse of test information function to estimate CAT reliability. And several independent variables. Here first, 3 IRT reliability estimate. I'm gonna compare 3 methods, and I'm gonna use 2 IRT model, 2 parameter, 3 parameter, and then I use different mean population followed by normal distribution, mean 0, standard deviation 1, and mean 0, 1, and standard deviation 1, and mean 2, standard deviation 1. So finally, I'm just summarize which method is better and how many items are appropriate in CAT to maintain good reliability perspectives. So here, true reliability estimate. Actually, when you do some simulation study, we assume we know that the true because we just generate from some specific distribution, but unfortunately, in the real data, we don't know true. That's the reason why we need to estimate reliability. True reliability actually can be estimated here, derived from the definition of classical test theory. So look at this reliability definition. It's kind of very similar classical test theory. So correlation between true and estimate equal the numerator, the variance of estimate, kind of observed variance, minus so error variance, kind of error variance in the classical test theory, divided by denominator again is a variance of the estimate. So definitely this definition came from the CTT, but we're gonna use the true data and estimate data in IRT. Here, the three methods of marginalizing problem is how to marginalize in the mean of variance standard error given data. So you can see the numerator in the right side. So three methods of marginalizing on the error variance for each examinee to estimate cat reliability or investigate in 4 conditions. I use 4 conditions. So here is the first estimation method, estimating mean. This is mean of variance of standard error. As you can see, was used to approximate cat reliability. So first method, correlation first method equal, again, numerator and the right side, left side variance of estimate minus his marginalizing error is expected error variance divided by the observed variance. This is kind of actually approximate as, look at it. Here you can use information, test information function. This equation exactly, this one is can be compute. Integral 1 divided by test information is marginalizing. Again, this error variance can be approximated by 1 divided by test information. So I use this formula to estimate IRT reliability. Second one, harmonic mean. Look at that. This is first variance and expected. Here's the expected error and then squared. This is harmonic mean, used to approximate the mean variance observed standard error. Second type reliability is variance of estimate minus this is as expected error variance and the square. This is harmonic. Second method, and divide by denominator the same. This is again second type approximation, also can be described test information. Again, integral 1 divided square root test information and then square. This is harmonic mean. Third one is Jen's inequality. This is very interesting. This is standard error can be computed is observed standard error with data estimate data is 0. This is a single point. So this is a standard error given estimate data equals 0, the single point. So third type reliability can be approximate based on this equation put here. Again, variance of estimate minus this is the standard error squared given data head equals 0 divided by this is a estimate variance. This is third type reliability. So we're gonna use 3 methods to estimate reliability in CAD. So I use data, emergency medical technician, version 22 test plan here, 5 content area, airway, the cardiology, trauma, medical, and the EMS. This is real data. So several conditions. So estimate IRT reliability, diagnose IRT models were applied to generate item response to 1,000 examining with following mean 0 standard deviation 1, mean 1 standard deviation 1, and mean 2 standard deviation 1. And A parameters was discriminant parameters was generated from log normal 0 and standard deviation 0.2 for 2 parameter. And C parameter was set to 0.25 to evaluate 3 parameter model. And the fixed test length, I use fixed test length as termination criteria, varied from the item 10 to 60. This is a little bit small number of items compared to previous research. So 10, 11, 12, 13, I use 50 test situation within 1,136 item pool. Actually, this item pool mean item difficulty is almost 1.0, right? So a little bit relatively difficult. So to estimate stable CAD reliability, estimate each condition, each test using fixed test ranks from the 10 to 60 was replicated 100 times. It takes long time to generate this kind of simulation studies in my computer. I think it's 1 week to finish this kind of simulation. And average empirical reliability was calculated and graphed. This is the condition. So how can you estimate reliability? Again, true IRT reliability were computed squared correlation between true data and estimate data. True data actually correlation. The true data is estimated from the complete data, 1,126. This is true data, and estimate data based on the CAT, 10 item, 11 item, 20 item, 30 item. Okay, and the 3 empirical CAT reliability were computed. Again, the arithmetic mean and harmonic mean and Jensen inequality. Ability estimate will calculate Bayesian procedure because MLE method does not compute mixed response. So Bayesian procedure until at least 1 item was answered correctly and 1 item was answered incorrectly. And then mixed response and then MLE works. Okay? So ability estimate basically based on MLE, but previous several items using Bayesian procedure. All CAT algorithm, content balancing, item selection is very basic based on and this is very basic items, content balancing, random scale 5. If you're interested in, already I wrote this paper. If you're interested in, I will send you. And for these studies were implemented by CAT-R package in the R program. So here is result. Reliability for different items. For here, this first graphs 2 parameter model with data mean 0, standard deviation 1. And I just will compare the first graph and second graph. This is the 2 parameter model, data mean 1 and standard deviation 1. As you can see, this is a population mean equal 1. It's very equal, similar to mean difficulty in the item bank. As we can see, across all number of items, 10, 12, 20, 30, 40, 50, 60, actually compared A and B, C, this graph, true reliability is higher than A and C, and also 3 reliability estimate also larger than A and C. So this is matches mean population ability with difficulty parameter in item bank. Now I want to compare this. Look at that. I just actually little bit different here. Here, yes, a solid line. Here, solid line is true reliability. So long dot line is here. Middle here is this is under here, and the arithmetic mean as short dot line. This is harmonic. This is Jensen inequality. So and large dot here, true and the arithmetic mean here. Really middle, you can see. So Jensen equality works well, very close to true, even 20 items. So Jensen equality inequality estimation method is very works well. So mean population equals 0. Because Jensen equation estimate the given data equal 0. So this is works well. And again, last one is 3 parameter model. Look at that. This is when the number of items is very short, 20 and 30, is very bad estimate. Even if true reliability is 0.8, 0.9, but still 40 item estimate. The reliability estimates less than true reliability, but at the minute item 60 almost close to true reliability. But 2 parameter, look at that, the 40 and 30 almost matches true reliability and estimate. So that is a very unique result compared to previous research. So this is tables. Again, I just put all this kind of result put in the like graphs. And result, here's three reliability estimate reliability become greater as number of items administered increase as terminus criterion for all conditions. It's very common. Okay. CAT reliability bound, this is very general. This is Jensen equality method, the reliability larger than and the harmonic mean larger than arithmetic mean. This is a very common, known in the previous research. But the mean of population ability is similar to mean of item difficulty parameter within item bank to estimate. Sometimes this sign is opposite. As you can see, look at that. Mean population equal to and the average item parameter. Sometimes this Jensen equality reliability is smaller than here. Look at that, smaller than. But this case, three case is this is larger than. But in this case, is almost equal. Sometimes this is smaller than this. So this is some different result in the compared to previous research. Finally, three CAT reliability always underestimate true reliability. As we can see, underestimate. Get that? Underestimate. Except that the Jensen and the equality overestimate after more than 30 from the 50 item were administered when the mean population ability is 0. Look at the figure 1 and D. Here, figure 1 and D. Little bit even here, short and long dot line is overestimate true reliability and overestimate true reliability. And three reliability estimate were close to reliability when the number of items administered was over 30 items. At least we need to administer 30 items for two parameter logistic model. As you can see, figure 1, A, B, C, and 50 items. We need more items for three parameter logistic model to recover true reliability in CAT. Three estimates were close to true reliability and perform well when the mean of item difficulty parameter was equal to mean of population ability. This is very interesting. Again, here, this one. This is actually we need to match it, mean population with the mean item difficulty within bank. Kind of, we need to decrease gap. And then the arithmetic mean and the harmonic mean were close to each other and consistent across all conditions. Actually, there is no big difference between two estimates. However, reliability estimate using Jensen inequality overestimate rather than two estimates. When the number of items increase, when the mean of population ability is 0, it usually little bit you get that. As Jensen equality is overestimate the other two estimate method. So conclusion, the one slide. So we have 1 minute. The number of items of the administrators were more than 50. Three reliability estimate would be appropriate in the three parameter logistic model. This is well known by Nicewan and Thompson. And for two parameter logistic model, after 30 items, just the 30 items administered in CAT, reporting three reliability estimates suggest regardless of population group, doesn't matter. However, this is third method using Jensen inequality, recover true reliability when only 20 items were administered for two parameter logistic model. Only 20 items exactly recover true reliability. Interesting. If the mean of population ability is close to mean of item difficulty within item bank, three reliability were almost identical each other and perform better the other population group. So recommend this case. right? It's exactly, very well recovered true reliability, in this case. Finally, in conclusion, Jensen equality, the reliability estimate using Jensen equality more efficient, accurate to estimate reliability, even a little bit overestimate when the mean of population ability is 0, but very efficient because this is a single value. You can compute this value using single value, very simple computation, also very efficient, easy to compute. So also very well recovered true reliability using this method. So that's my finding in my study. As a reference here, so that's, I think, time's up, right? Thank you. Any questions, comments? Yes?
I have a question. So it seems like what you're doing here is using these three numerical approximations for reliability, which are about Q1, right, at the classical. We're treating the correlation of true data and estimated data in simulation as true reliability.
Yes.
Is there a reason we don't consider that just to be the estimated reliability? So if you want to estimate reliability on a cat, you just run Monte Carlo simulations on your other bank and calculate that correlation, and that is the estimated reliability.
As I understand, actually, so we don't know true, right? In the real data.
Yeah, but you will know what the parameters of the item bank are in real life.
Yes.
Yeah. So if you just take those parameters of the item bank, run a simulation on 10,000 examinations, Monte Carlo, and run that calculation, that gives you an estimated reliability.
Yes.
And apparently the best is.
What?
Sorry. Your simulation-based correlation,
Yes.
you consider that the best estimate of reliability?
Yes.
So my question is, do we need the other three?
Do we need other three?
Yes.
And then that's how you measure whether the other three are reliable, or how do you work for it? How you doing that?
Like, it'd be nice to have a theoretical base, numerical. It seems like those three estimates are not the best. So I'm wondering if we use simulation because there's no numerical solution.
You're comparing your three reliability coefficients to a fidelity coefficient. And they're never actually going to come together. If you took the fidelity coefficient, and it's like the square root of square root of this, you'd probably get a reliability. But right now, you have theta versus theta hat, which is what you get on the simulation. And if you were to do the appropriate transformation on that, you would get a pretty decent estimate of the reliability of the test. Without having to worry too much about being more complicated. The other approach would be to use homogeneous modeling. It's kind of doing the same thing that we used to test. It's basically getting the marginal velocity based on a series of theoretical. It seems like, although I like to study, I haven't studied very well. I'm not sure whether I'd go back and start using these methods for reliability. Since I already have at least a simulator, and I have some procedures for creating marginal reliability. Is there anything in your results that would indicate that it's kind of dangerous to have one reliability coefficient that you would use for short tests and a different reliability coefficient that you would
reliable estimate in the past. So they use kind of the simplest kind of and the estimate mean to marginalize the mean error.
The registry exam was using those?
Yes. So simply, but I'm not sure which one is errors, and as you can see, I just assume that if you use different method, harmonic and the potential equality more close to true, that a little bit improved. I'm not sure how much was significant, but when I see this kind of research in the when you use very small number of items, if you use maybe dangerous to use the arithmetic mean and the harmonic. Maybe density equality more works and better and when you use small number of items because it's close to reliable. But if you use more than 50 and 60, 80, it usually nice one as Simon said, 8 items, 9 items, the three methods is exactly almost the same, provide the same estimate. So which one is, you cannot say which one is better, but if you use very small number item, and then I recommend then equality. And also maybe depends on also population, mean population or some item models or depends on item bank characteristics. Still there are lots of issues here, but sure for generalize all kinds of this research for all all cases. Any comment? Complaint? Thank you.